In this video, we are going to look at how to set up Big Data Fabric. To give context of the work, we'll first briefly look at what is Big Data and what is Big Data Fabric. Big data deals with data sets that are too large or complex to be dealt with traditional data processing applications. It involves data source, capturing data, data storage, data analysis, search, sharing, transfer, visualization, querying, updating, information privacy, etc. Big Data Fabric stitches together data silos in big data to represent organizational information holistically. Here, we can see structured, unstructured, and semi-structured data on the left-hand side. It gets ingested into big data system where it gets stored and processed upon. Data catalog exposes this information to data marts. Data marts can do further exploration like visualization, reporting, etc. We will look at Big Data Fabric with a simple example of house sales data of Seattle. We'll look at 3 stages of ingestion, building data mart, and analytics. We will look at AWS Cloud Native implementation for this with various AWS services. For ingestion, we'll use AWS Glue. For data mart, we'll use Athena. And for analytics, we'll use QuickSight. Let's look at the demo of how to set this complete Big Data Fabric from scratch in AWS Cloud Native way. So I'm switching to Management Console of AWS. So we already have data uploaded to S3. So for uploading, we can use things like the Management Console GUI or AWS CLI. So this Seattle house sales data has been uploaded to a folder called house sales in one of the buckets that I have created on my data. So once this data is there in S3, we are going to ingest it or import it using AWS Glue. So let's change our service to AWS Glue. In AWS Glue, there are tables, connections, crawlers. So I'll switch to crawlers. So I'm going to create a crawler for ingesting our data. So the name has to be given. So I will give the name of house sales for my crawler. Then we have to choose data store. So we'll say crawl all folders. Now it is in S3. So the path is what I will browse through using this. So it was in the all skills bucket and it was in the house sales folder. So I will give the house sales folder as my selection. So you can also give exclude parameters if you want to exclude some folders, but I have only house sales data. So I'm not going to give any exclude pattern. Then we say next. So we have only this data store. So I'll say no. The role has to be in such a way that it has access to Glue as well as S3. So I have already created such role. So I'll use that role, which is the AWS Glue service role -Samir. So this is important. The frequency can be hourly, daily, or you can choose number of days or weekly or monthly, or we can even run it on demand. So I'm going to run it on demand so that after creating crawler, we'll run the crawler to ingest the data. So you can either do add database where you can create a database and use that database for storing your ingested data, or you can choose an existing database. So I will use an existing database, Samir test-db. So now the last option it gives is to preview everything that you selected. So we created a crawler house-sales. We gave the data store, which is the S3 data in all skills bucket in the house sales folder. The iron role that we gave as the AWS Glue service role -Samir. We said the schedule is run it on demand, and we give a database of Samir-test-db. So we finish creating the crawler. So once we create the crawler, it will show up in the list. So this is the crawler, and I'll say run crawler so that it will start crawling the data. So now it starts fetching the data from S3 and starts getting it into Glue. So what we did was we did the first stage of ingestion of data using AWS Glue, and we created a crawler and we started calling the data from S3 into AWS Glue, which started getting data into our big data system. So you can refresh this to see the status of the crawler. So it is starting and it will take some seconds. It will take roughly 40 seconds. You can also refresh it using the browser refresh button. And it is crawling the data. It's still crawling the data. So after ingestion, we are going to build a data mart using Athena. So once this data is crawled, which we can see here, so we can look at some previous jobs. So this test crawler 2, so you can also see the logs once it's completed. These are the CloudWatch logs. It will give all the information about the crawler. It will say what all data got ingested, imported. So it says what data got crawled. And so it says table, it created a table S in Samir test DB. This was the AWS CloudWatch. So what we'll do is we'll go into Athena, and if this data is not ingested, we'll use some earlier ingested data. So in Athena, what we have to do is we have to give a data source. So the data source is AWS data catalog. The database is Samir test DB. So as you can see, our house sales data is not yet ingested. So we'll look at the earlier ingested data of S table that we saw in the earlier job, earlier crawler that was created. So this is the same table. So this has different columns: ID, date, price, bedrooms. So this is a standard house sales data. We can even preview this table. So this preview is going to give the first 10 rows, and you can see the data in the table as ID, date, price, bedrooms, bathrooms, right? So now this data is ingested in Athena. So now what we have done is we did the ingestion using AWS Glue. We built the data mart using Athena that we saw by making some queries, and we saw the data. Now we'll switch to QuickSight. So this is for the analytics part. So what we'll do is we'll go to QuickSight. So this QuickSight opens up the console of QuickSight. We have to choose a data set here. So again, our house sales data is not here, but so we can do a new data set, and it has to be done through Athena. So I'll call this data source as house sales. We'll create a data source. And again, you give the AWS data catalog. The database is Samir test DB. And now we see the house sales data, right? So our crawling has happened now. So we'll look at this data in the visualization. So either you can directly query the data or you can import to Spice for quicker analytics. So we'll import to Spice for quicker analysis. So we are going to visualize this data. So as you can see, you see all the various columns here in our data, various visualization types here like donut chart, pie chart. So let's select the vertical bar chart, and let's look at distribution of data with bedrooms. So as you can see, it's a Gaussian-like distribution with 3 bedrooms. The number of houses are largest, like 10K, 10,000. As the number of bedrooms decrease, the number of houses also decrease, as well as number of bedrooms increase, the number of houses also decrease, right? We can also see that in a pie chart. So as you can see, the number of houses is the largest with 3 bedrooms. Then the lower number is 4 bedrooms, then 2 bedrooms, 5 bedrooms, 6 bedrooms, so on and so forth, right? We can also add a visualization here. So I'll add a visual, and let's do a scatter plot. So I'll do a scatter plot of square foot living, the square foot living area on the x-axis, and price on the y-axis. So as the house is larger, the price is larger, right? That inside you can see from this plot, the lowest price is increasing with square foot living, right? So we can also do some cool visualizations where I will add group or color by floors. So you can see these colors plotted here. And maybe what I'll do is I will do the size by bedrooms. So here, the larger the area of the circle, the larger the number of those values, right? So we won't go into all the details of visualization here. But what we did was we did ingestion using AWS Glue. We did the crawler, right? The crawler crawled the data, got it from the S3 into AWS Glue in our big data system. Then we built a data mart using Athena. So we ran some queries, we saw the data. We did the analytics using QuickSight. So we did some visualization, we did some drill down, and we saw the insights. And we saw the insight that as the house becomes larger, the price of the house increases. So we saw a simple big data fabric setup on the Seattle house sales data example. And similarly, we can also set up machine learning model to predict sale price for any house that comes up on market. We can also set up AWS Neptune graph database for our data. But all that we'll see in our next video. So I hope you found something meaningful, and good luck exploring Big Data Fabric.